One of the things that you need to pay attention to in the C programming language is the declaration of variables that you plan to use. Variables hold data, and there are different types of data. And by declaration, we need to define the type of data when we want to declare a variable as to what that variable will hold. Okay, so we're going to walk through some of the considerations for that specific to the C programming language. This is a tutorial. You can find this tutorial on the tutorial pages, and this one is data types. Now, there are modern programming languages like Python, if you've used Python. R is another one that infer data type when you introduce data to the program, and most of the time you don't need to explicitly declare it. Now, back in the days when C, and I've mentioned before, what a super influential program, still in very wide use in many, many programs. It's very fast and it's very efficient. And one of the restraints on programmers back then was memory. Memory was very expensive. Memory structures, physical memory on computers was very small. And so managing that computing requirement for memory was a big deal. It was a part of the craft of programming. Still is, especially for high volume data, big data, streaming data. For data science, when you're using small data sets, because memory structures are so large compared to just a few years ago in the scheme of things, and relatively extremely cheap. There's been an exponential decrease in the cost of a given unit of memory. We tend not to think about it, and yet it's one of the fundamentals that you'll be much stronger if you're aware of it. Let's look at some of the data types in C and get used to them. One of the fundamental ones is int. It's just an integer, 1, 2, 3, 4, etc. No decimal value. It stores 4 bytes of memory. Now that's quite a lot. And with 4 bytes of memory, we can go from negative 2 to the power of 31 up to positive 2 to the power of 31 minus 1. Why minus 1? Well, because the positive range includes 0. We can also give a qualifier to the integer data type when we declare it, and declare it as unsigned. Now what that means is that we'll only get absolute values or positive values of that, and that goes up to 2 to the 32 minus 1. And of course, that's because it also includes 0 in the range. The char or char data type is used to store single characters like letters or symbols, and it only stores 1 byte of memory, just 8 bits. And remember the 8 bits, we had an example of this in class. It goes from negative 128 to positive 127, of course including 0 is why it doesn't go to 128 in the positive direction. And remember the mapping of this kind of variable on the ASCII table. This is a way to map characters to letters to represent those in computing language, zeros and ones. Floating point. This is probably one of the more important ones that you'll use a lot for any sort of numerical work that you do. Floating point just means that there's a decimal point and a precision value afterwards. Now, where it was pretty easy to define the range of an integer, logically satisfying with a number of integers, the whole range of the magnitude of values that could fit in there. We can't do the same thing with float. Why not? Because the magnitude of values for float is defined by the precision that you need. So the floating point value takes up 4 bytes of memory, 32 bits of precision, which might have an integer part that is big, but really we use these when we want a lot of precision. And what if you even need more than that? What if it was an application? This is a really important point for memory allocation. Remember, what would it have been like in the 1960s, even the 1950s, when when space agencies were designing craft to go through space, and now going to Mars, back then going to the moon. The precision of calculations must be very precise, or you're going to go wide of your target if you're making rounding errors here on Earth. And so what if you need even more than a float? Well, we have the double. It's twice the amount of memory, even more precision. So we have to think of the precision that you actually need if we're going to be most efficient when we're declaring floats and doubles. Often we may not need a double for some calculations, and then we would always go with float. And sometimes the thinking is that if you're just dealing with small data, why not just do a double? Memory's cheap, but that might restrict and will restrict the scaling of your program. So this is part of the art and craft and design of computer programming languages, and you'll do well to invest in thinking about this. Here's a unique kind of data type. Now, void is a type, but we actually don't use it to store any data. That's a little counterintuitive. What does it mean? Well, a function can return a type of void, and that just means it doesn't return any value at all. It's a null declaration. And also, likewise, the parameter list inside of a function can also be void. All that means is you do not need to pass a value to that function for the function to work and do the work that you want it to do. So you can just kind of think of void as a placeholder for null, or a placeholder for the absence of some data. Now, those are the 5 primary types that are built into C. We've also included 2 more types that you'll have access to through the CS50.h header. And one is Boolean. We talked about this in the conditionals when we went over conditionals. If you don't have conditionals in your head, it's worth looking back at the lecture for that. Now, a Boolean is a value that just takes true or false. Now, I use Booleans almost every time I program, doing data science programming, doing data analysis programming, doing statistics. I use it for a lot of things. I use it to set up conditional arguments. I use it to select data that adhere to certain conditions that I define. It's true and false are the 2 values that a Boolean can take. And numerically, that's equivalent to 1 and 0. True is 1, false is 0. If you're going to use the bool type to access those Booleans, you'll need to include the CS50.h header. String is another type, whereas the char is just a single character in in quotes. The string type is a whole bunch of characters, up to I can't remember how big it is, but I think it's 4 bytes. So quite a large amount of text will fit into the string variable. And it's enclosed in double quotes. It includes spaces. It includes punctuation and special characters. Again, you require the CS50.h. Now, you're not limited to these basic types. These are the basic, shall we say, atomic types of data structures. We can also combine data types into structs, and we'll learn about structs a little bit later on. But that's not all. We can also define our own data structures with type defs. This is, give you unlimited flexibility in designing how data flows and how your programs access data. Now let's have a look at the syntax for actually declaring variables. If you wanted to declare an integer and we wanted to call the integer the variable named number, we'd simply, at the top of our program, type int number. And the syntax highlighting should indicate int as a special declarative statement, and highlight the color. Semicolon at the end, of course. Char letter would hold a single letter. If you have several variables to define and they're of the same type, you can do it in the same line. So int, height, and width, and we just separate the different variables we want to create with the comma. And the same thing with float or any of the other types. Here's 3 floats, square root 2, square root 3, and pi. It's Also, a final note is it's good practice only to declare the variables if you actually use them in your program. Sometimes when you're designing your program, you may have an idea, oh, well, I need these 3 variables and only end up using 2. This can be confusing in your program, and it deviates from best practice and style. So pay attention to that. Remember the rule of thumb here is you're designing these programs to be perfectly clear for another person that you respect and who may read and use your code in the future. Maybe you're a little afraid of them, someone you really respect. And it also goes for your future self. The clearer your program is with no extraneous stuff in it, it will be much easier for you to figure it out in the future, need you do so. So here's how you use them. We've got our declaration statement, int number, and here we're assigning a value to number with the assignment operator equals. Do the same thing with character. Here we're assigning that char with a capital H. We can do this declarative statement and the assignment statement all in one step. We usually call that initialization, where we declare and assign in the same step. And we might do that by int number equals 17, all on the same line. This is probably the most common way to do it if you're using one-off variables in for loops or just in a little part of your program. I think the thing that I would say to end this up is that declaring variables and laying out the variables that are part of your program, it's a little bit like cooking a fantastic meal. It's a bit of the preparation work that you've planned this fantastic meal. And mise en place is a French term that means you're laying everything out. And laying out the variables and initializing them, it's a bit of your mise en place for making a fantastic program. That's all I have to say about that.